Hello everyone, I'm Mahfouz Rahman from University of Minnesota. In this presentation, I'm going to briefly introduce standard-free assessment of replicated genome-wide CRISPR screens. The recent advances in CRISPR-Cas9 technology has led to the generation of many genome-wide single mutant and double mutant loss-of-function screens. However, little work has been done to fully characterize the reproducibility of genome-wide CRISPR screens, especially those that focus on identifying differential effects. If we have a ground truth gold standard, it is quite straightforward to evaluate the quality of genome-wide screens. For example, for single mutant screens, we can use an essentiality-based gold standard to measure the quality of a screen by counting the number of essential genes estimated by that screen. However, the development of such gold standard is difficult, and therefore they're often unavailable. As an alternative, we can systematically summarize the agreement of many replicated screens. Here we introduce a systematic approach called jitter that, given a set of replicate genetic screens, uses an MC-MC-based approach to jointly estimate false positive rates, false negative rate, and calculate a consensus posterior probability profile on the observed effect. In our first application, we use jitter on 5 single mutant replicate screens. Focusing on genes exhibiting at least a two-fold change, we applied jitter to jointly estimate a consensus set of essential genes and the false positive rate and the false negative rate. We further evaluated the single mutant effect, called set a range of effect size thresholds, and measured the corresponding precision recall characteristics. The analysis showed high reproducibility of single mutant effects. Then we used a similar approach to find the reproducibility of differential effects. Our analysis does the first robust estimate of reproducibility of differential effects in CRISPR screens, and we found that it is more difficult to reproduce than compared to single mutant effects. If you're interested in the work, please visit my poster for more details and let me know if you have any questions or comments. Thank you for your attention.